Imagine trying to count something, like these dots. Now, imagine your language didn't have words like one, two, or three, only vague terms like a few or many. Do you think you could keep track of exact amounts, like remembering whether there were 6 or 7 objects? And more importantly, could you actually do that reliably? Linguists became interested in that question while studying a group called the Piraha, a small community living in the Amazon rainforest. Their language is unusual because it doesn't have exact number words. Instead, it uses more general terms to describe quantity. And that led researchers to a bigger question. If a language doesn't have precise numbers, can its speakers still think in precise numbers? To explore this, researchers designed a series of experiments to test how the Piraha understand quantity.
So if the Baraha don't use numbers, how do they talk about quantities? At first, researchers thought they had words for one, two, and many, specifically hoi, hoi, and lagiso. Take a look at this graph. The researchers did a test where they added spools of thread one by one, and then did another test where they took them away one by one. The x-axis here is the actual number of objects on the table, and the y-axis is the percentage of times that Baraha used a specific word. When researchers added spools, hoi, the black bar, always meant one, but when they subtracted spools, the Baraha used that same exact word, hoi, for up to 6 objects. This means these words aren't absolute numbers, like saying, I have exactly 3 slices of pizza. Instead, they are relative terms, like saying, I have a few slices, or I have fewer than before. They are contextual. So if they don't have absolute numbers, does that mean they can't understand exact amounts at all? This brings us to a fancy linguistic theory called the Strong-Worfing claim. Basically, this term just means language strictly creates our concepts. If you don't have a word for a number, you literally cannot understand the concept of exact quantities. To test this, researchers played a matching game. They put down a certain number of spools and asked the Baraha to put down the same exact number of balloons. Looking at the second graph, the x-axis is the number of spools the researcher put down, and the y-axis is the number of balloons the participant matched it with. Those little black dots, those are perfectly correct answers. When the Baraha could physically see the spools right in front of them, they matched them perfectly, even for big numbers. This completely busts that Strong-Worfing claim. They do have an exact concept of exact quantity. But here's the catch. When researchers hid the spools behind a wall or dropped them one by one into a can, notice what happened. All those little X marks scattering everywhere represent incorrect answers. In other words, the higher the number of hidden spools, the worse the memory got. So, what's the big takeaway? The researchers realized that number words aren't needed to see an amount in front of you. Instead, numbers act as cognitive technology. Think of number words like the RAM or memory in your computer, or even just a mental sticky note. They are tools we invented to store data so we can remember it later on. Without that tool, it is incredibly hard to hold on to exact figures in your short-term memory.
So in a way, the difference isn't whether people can understand quantities at all, it's whether those quantities can be held onto when they're not right in front of you. And that's where language seems to step in. Not by creating the idea of numbers from nothing, but by giving us a tool to keep it stable in our minds over time.